Right, so the last thing we're going to look at in section 2.2, it's really kind of three separate things. One thing is what happens when you get angles that are in other quadrants. So still multiples of 30 and 45, but now in quadrants 2, 3, or 4. We're going to look at how we can also do this if we don't have a unit circle. Everything I've shown you this week has always made it on a unit circle, which means the radius is how big? How big? 1, yeah. You don't have to do it on a unit circle. You can do it on a circle of any size. So I'll show you how that works, and it's pretty much the same as what we've been doing. And then the last thing I'll show you is the calculator and how you type in like sine, cosine, cotangent on the calculator. Okay, so that's basically what I just said. So we're going to look at finding the 6 trig functions of multiples of 30 and 45 and 60. Okay, so same triangles as yesterday. So we still have to know those numbers. What are the two fractions that come up in the 30-60?
1/2 and root 3 over 2.
Yep, so we're still going to use 1/2 and root 3 over 2 for the short and the long side, respectively. And what about for the 45-45? Yep.
Root 2 over 2.
Root 2 over 2. Still going to use those same fractions. Also, since we've been doing it a lot, I'm not going to do all 6 trig functions in every problem. Okay, the first one, we'll try finding all 6. But then after the first one, I'm just going to ask you for like one problem. Okay, just the cosecant, just the sine, just the cosine. That's more of how it's going to be on the test. Okay, but we'll do one more where we practice all 6. Okay, so they want us to find the 6 trig functions of 135. Okay, first thing we got to figure out is when we draw 135, roughly where it is. Okay, so on that circle, where is 135? Yeah.
It's in the middle of 180 and 90.
Right, it's exactly in the middle. If you take the difference between 90 and 180 is 90. Well, if you go 45 away from 90, you're at 135. And you're also 45 away from 180. So you're exactly in the middle. Because you're exactly in the middle, that tells you whether it's going to be the 45-45-90 or the 30-60-90. When I draw this triangle, which one is it going to be? If you're not sure, just think 135, is it a multiple of 30 or is it a multiple of 45?
It's a 45.
It's a multiple of 45. If it's a multiple of 30, it has to end in a 0. Okay, ending in a 5 can't be a multiple of 30. Okay, so there's my triangle, and it's the 45-45-90. 45-45-90. If you're not sure why the angles are both 45, well, just look at the difference between 90 and 135. How much is that? To get from 90 to 135.
45.
That's 45. That means this part right here is 45. This part on the outside. Well, if the quadrant makes a 90, and this part is 45, then the part on the inside has to also be 45. That's how it makes a 90. Okay. All right, so now let's label these two sides. Okay. So Allie, in the 45-45-90, both sides are what fraction?
Root 2 over 2.
Yep, they're both root 2 over 2. Now, the thing we have to be careful about is when we make the coordinate for 135, take into account that you're in quadrant 2. Right? How is that going to look when we write the coordinate? one of those numbers is going to have a what?
The x is negative?
The x is negative. Okay. Other than that, it's exactly the same coordinate as 45. So you went left, root 2 over 2. And left means negative. And then you went up, root 2 over 2. So having that negative is really the only thing that's new. Now we just do the same thing. Okay, so let's write out our 6 trig functions. Okay, so Connor, what would my sign be?
It'd be root 2 over 2.
Yes. And this time, if you mix up the x and the y, you would get the sine and the cosine wrong, because one's negative, one's positive. Okay, Jasmine, how about my cosine?
Negative root 2 over 2.
Yep. So that's the cosine. And my tangent. Caitlin, what's my tangent? Negative 1, right? We're dividing two things that are the same, except one's negative. So it's like we're dividing opposites. Anytime you divide opposites, you get negative 1. Right? So Ben, if I wanted to do the cotangent, just because that one's probably the quickest one, what do you get when you do the cotangent?
Not sure.
Do you remember how you get the 3 on the right in general once you have the 3 on the left? Anyone remind him? What do? You flip them. Yep. So we just flip them.
That would be 1.
Not 1. If you flip negative 1, you don't get 1. What do you get if you flip negative 1?
Would it still be negative 1?
It's still negative 1. Yep. When you flip a number, the sign of it never changes. Just change the numerator and denominator. Okay, how about, Libby, how about the cosecant?
It would be 2 square root of 2 over 2.
All right, it would be 2 square roots of 2 over 2, and then what would cancel out?
Oh, so it would be 2 square root, or the square root of 2.
It would just be the square root of 2. Yep. So anytime you flip root 2 over 2, after you fix it, you just get root 2. And then what about my secant? There?
Negative square root of 2.
Negative square root of 2. Yep. And that's the 6 trig functions for 135. Okay, any questions on that? All right. So now the rest of them, we'll just go through one trig function per problem. Okay, cosecant of pi over 4. Okay, Peter, what's the first thing I have to do to figure that out? Yeah, it might be helpful to put it in degrees. Ultimately, what do you need, though, to do this? That might help you get what you need, but eventually you have to figure out the what. To do any problem in unit circle trig, you always need to know. All right, well, let's change it to degrees first, and then I'll ask you what to do next. So how do I change that to degrees? Yep, so we're going to do 180 over pi. Pi's cancel. 180 divided by 4 is 45. So what I really am trying to find is the cosecant of 45 degrees. But in order to do that, what do I need to know about 45 degrees?
Square root of root 2 over 2, the coordinate?
Yeah, I need the coordinate. So without the coordinate, I can't figure out anything. So that's the first thing I'm going to do is write down my coordinate. So here's 45 degrees. Hopefully this one, if you memorize it, you don't have to draw this one out. Sometimes with the 30s and 60s, you need to draw them to kind of get the right order. But the 45s, you really don't need to draw it out. So what's my coordinate for 45 degrees? Yeah.
Root 2 over 2 and another root 2 over 2.
Yep. So root 2 over 2, comma, root 2 over 2. All right, now I want the cosecant. Okay, I don't have to find all 6, just that one. What's the formula for cosecant, Aaron? Or how do we get cosecant?
You put the sign.
And what letter is the sign?
Y.
It's y. So the formula for cosecant is 1 over y. You just flip the y. Okay. When you flip root 2 over 2, we just did it in the last problem, what do you get? You get the square root of 2. Okay. So that's how the test will be set up. I'll ask you what the coordinate is, and then I'll ask you what the answer is to that specific trig function. Questions on that? All right. Let's try the sine of 225. Right, so Aiden, what would I do first here?
Find out where D25 is.
Okay, yeah. Yeah, let's put 225 on the circle and then kind of figure out where it is. So here's 180. Here's 270. It's somewhere in between. So you have 3 options. It's closer to 180, closer to 270, or is it right in the middle?
Like right in the middle.
It's right in the middle. Yep. Remember, if it ends in a 5, it's a multiple of 45 for the kind of angles we're working with. So it has to be the 45, 45, 90 triangle. So here's my triangle. 45, 45, 90. And Jake, in the 45, 45, 90, each side is how long? What's that fraction? It's got a square root in it.
Square root 90, 45.
So it's in the 45, 40, like in the 30, 60, 90, we have 1/2 and root 3 over 2. Those are the 2 numbers we use there. But there's a fraction we always use in this one. It's kind of like root 3 over 2, but it's just one thing's different. One number is different.
I don't remember.
Not sure, anyone help him out? What's the... Yep.
Square root of 2 over 2.
Both sides are square root 2 over 2. Okay, now when we write the coordinate, just make sure we take into account we're in quadrant 3. So what's going to happen there? They're both negative. Negative root 2 over 2. Negative root 2 over 2. And now they want the sign value, which is the y, and the y is just negative root 2 over 2. So there's nothing to flip or divide at all here. So that is the sine of 225. If you type that in on a calculator, the reason we're not using a calculator for this is because watch what the calculator gives me. Negative 0.707106. It doesn't give me that number, negative root 2 over 2. Okay. But watch if I type in negative root 2 over 2 on the calculator, watch what I get. Negative root 2 over 2. I get negative 0.707. That's exactly what I got on the calculator when I typed it in. It's just the calculator doesn't give me this fraction. It gives me a decimal, which we don't want the decimal. We want the fraction. Right? That's why we do it this way. Questions on that? Right, and let's try, we have one more 45-degree angle we can do. So let's see what this one comes out to. Kayla, what's the first thing that we could do here to make it a little easier?
Change it to degrees.
Yep, you could change that to degrees. And if you change 7 pi over 4 to degrees, you multiply by 180 and you divide by pi. Right. So the pi's would cancel and you end up with 7 times 180 divided by 4. 315. Okay, so now figure out where 315 is. That's 270. And that's 0, but it's the same as 360 going all the way around. Okay, so 315. Closer to 270, closer to 360, or right in the middle? Yep. Ends in a 5. It's going to be a multiple of 45. 45 degrees is halfway through the quadrant. It's right in the middle. And Ben, what's going to be my coordinate for 350?
Square root of 2 over 2 and the square root of 2 over 2.
Like that?
Yeah.
And what's the next one?
The square root of 2 over 2. Or is it a half?
Well, we're in quadrant 4. So if I put positive,
Negative,
it would put me
negative.
up here. Yeah, it's going to be negative. Now, if he forgot the negative, you would lose points for the coordinate. But would you still get the cosine right? This time you would have, because the negative that he forgot was on the y value, which has nothing to do with cosine. So you still would have gotten like partial. But that's the correct coordinate, and this is the correct answer. Root 2 over 2. So any questions on working with the 45s? All right, let's try angles that don't end in a 5. Okay, when it doesn't end in a 5, like 120, 150, 210, 240, 300, those are all multiples of 30 because they don't end in a 5. So let's graph this and let's see where 120 is. So Devin, where's 120? I know it's in the second quadrant, but closer to 180, closer to 90, right in the middle.
Closer to 180.
Um,
90.
so yeah, how far away from 120 is 90? So like if you had, like, think of like $90, you had $90 and you want to buy something for 120, how short are you? 30, yeah, it's 30 away. So it's closer to 90 than it is to 180. So let's put the dot closer to 90. It's probably not even that close, but if you exaggerate it, it just makes your picture even clearer, which side is the short side and which side is the long side. So always draw your hypotenuse to the origin and draw your height perpendicular to the x-axis. So just like that. All right. So now this is going to be the 30, 60, 90 triangle. Kayla, in the 30, 60, 90, what are the two sides again?
Square root of 3 over 2 and 1/2.
And how do I know which one goes where?
One of them is the short side, one of them is the long side.
Okay, so one of those numbers she said is always the long side, and the other one is always the short side. Which one is always the short side?
The
1/2 is always the short side. There's the short side. There is the long side. So now we should be able to write the coordinate for 120. Connor, what's going to be the coordinate for 120?
It's going to be 1/2 and then root 3 over 2.
Like that?
Yep. Oh, wait. The x would be negative.
Right, the x would be negative, which in this case, would that make a difference when you're finding tangent? Yes, because x is part of the formula for tangent, so it would mess us up. Okay, so -1/2, root 3 over 2. Allie, what's the formula to find tangent? Y over x. So we want y over x. Okay, and when I divide those out, Jasmine, what's going to happen?
The 2's cancel out.
2's are gone. And what do I end up with?
Negative square root of 3.
Yep. And that's it. So the tangent of 120 is the negative square root of 3. Again, if you type that in on the calculator, tangent 120, you'll get a decimal. It won't give you this. But if you type that in, and you type that in, you could check and see that they are the same decimal. Okay. Questions on that one? All right. Let's try secant of 690. Okay, so something's happening here. We've done it before. We haven't done it today, but we got to fix something before we start. Yep.
Can we just subtract 360?
Yeah, let's subtract 360 just to make that angle smaller. So 690 is really the same as 330. Now, just by looking at it, is 330 a multiple of 30 or 45?
30.
It's a multiple of 30. Yep. So when I draw this, it's going to be closer to one than the other. It's not going to be right in the middle. So here's 270. Here's 360. So 330 is almost all the way around. Oh, right there. Okay, make our triangle. And it should be very clear that we've got a short and a long side. Caitlin, what's the long side going to be here?
Square root of 3.
That's always root 3 over 2. And if you don't remember where that number comes from, we used the Pythagorean theorem yesterday to figure that out. Okay. And then the short side is, Ben, how long? 1/2. Okay, so Libby, when I write my coordinate for 330, what's it going to be?
The root over 3 over 2.
Yep.
And then negative 1/2.
Yep, 3 over 2, negative 1/2. Okay. So we've got the coordinate. Now they want the secant. Yeah.
How do you know if the half goes first over the 3, square root of 3 over 2?
So how do we know which one goes first there? Somebody explain that?
The x is longer than the y.
Right, you always write your coordinate x comma y.
And then 3 over 2 is longer than half.
Yep. And the long side is always the root 3 over 2 because that number is bigger than 1/2. Bigger number goes with bigger side. Okay, so secant. How do you get the secant? What's the steps for that? Yep, Aaron. It's 1 over x. So you take the x value and you flip it. Okay, Ellie, if I take the x value and flip it, what do I get?
2 and then root 3 over 3.
So 2 root 3 over. Well, the root is going to be gone from the bottom,
Oh, yes, it's
right?
just 3.
So it's just 3 because we don't want the root in the bottom. So it's 2 root 3 over 3. And that's your secant. Questions on that one? All right, so I mean, we could do 30s and 60s in every quadrant. I mean, here's another one. I'm not going to go through the whole thing, but it's -7 times 180 divided by 6. So you're dealing with a negative 210 degree angle. I just want to know what you'd have to do here to make that a little easier.
Yeah, add 360.
Yeah, you'd add 360, and you'd see that that's a 150. Okay. So now you're dealing with a multiple of 30 again, which is going to involve a 1/2 and a root 3 over 2. All right, so I'm going to show you a picture of basically everything that we've done all weeks to this point, all at the same time. So you've already done all of these. I've just never shown you it all at the same time. That's a lot to draw, so I wouldn't draw all that out. But if you look at the triangles in blue, actually, no, let's start with the ones in red. The ones in red are all the root 2 over 2s, both positive In quadrant 3, they're both negative. And then in quadrants 2 and 4, one of each. Either the x is negative or the y is negative. Okay, but all the ones in red are your root 2 over 2's. All the ones in green, those are the 30s. Those are all root 3 over 2, 1/2. Root 3 over 2, 1/2, root 3 over 2, 1/2, root 3 over 2, 1/2. The only difference between the different quadrants is whether you put a negative in front of the x or the y, or both. And then the blue one, that's your 60. The blue ones are all 1/2 root 3 over 2. Okay. Again, just sometimes you put a negative in front of one or the other. So as long as you know what I just circled, that's all you need to know to do that whole picture. Just the 3 that I circled. Right? Now the other ones, we did these the very first day. Sometimes people forget about those. Those are the easy ones. Right? The coordinates all have a 1 and a 0 in them because they're all on the axes. Right? So knowing those 1, 2, 3, 5 things that I circled does everything that we learned all week so far. And that's how you do unit circle trig. So there's a total of 3, 6, 9, 12, 13, 14, 15, 16. So there's 16 different angles that you should know how to find the coordinate for. And for any one of those 16 angles, I could ask you for the sine, the cosine, the tangent, cosecant, secant, or cotangent. Right? So I'll pick some of those 16, they'll be on the test, and I'll pick some trig functions, and you'll just find what I asked. Okay. So any questions on that? All right. So I told you that everything we've done up until now has been on a unit circle. The only reason we've done a unit circle is because the radius is a 1. 1 is easy to do with arithmetic. Well, it doesn't have to be a 1. It could be a circle with any radius. All right. So let's look at what happens if we have a point that's not on the unit circle. All right. So let's say that this is my unit circle. That small circle in the middle has a radius of 1. And what I'm going to do is I'm going to put, do it like this. I'm going to put a point on the circumference of that small circle. I can even move the big circle for now. I can put it back in a second. So I've got a unit circle, and I've got a point on it somewhere. Okay. What angle is it? I don't know. It doesn't really matter what angle it is. Okay. What I'm going to do is I'm going to take that small circle and I'm going to scale it out. Right? I'm going to make a bigger version of it. On the bigger circle, that point, all I have to do to find out where it would be is draw a line right through it and see where it ends up. Okay. So these two angles, if I draw them, this one and this one, do it in green, are exactly the same angle. Just separate them so you can see them. Does everyone agree that the angle in red and the angle in green are exactly the same size? I mean, you can draw the sides as long as you want, you know, but they're the same size. It's just now it's on a bigger circle. All right, so let's figure out how we could use what we already know to do this. Okay, we don't have to learn new formulas really. We just have to see what happens to x and y. So let's call this r. So r is the radius of that big circle. I don't know what it is. Maybe it's 5. Maybe it's 5 times as big. Maybe it's 6 times as big. But it's bigger than that unit circle, which has a radius of 1. So we know how to do everything on a unit circle. So all we have to do is basically take that big circle and imagine shrinking it back down, right? If you can shrink it back down so that it's the size of a unit circle, then you can use all the formulas you already know. We just have to shrink that down. Okay? And in geometry, that's called scaling. Right? Sometimes you scale something and make it bigger, but we want to try to think of making that big circle smaller so it's back to what we're used to. A small circle with a radius of 1. All right, so we've got small circle where the radius is 1, and we have a big circle where the radius is r. Yeah. So, there's 3 things we have to look at. We have to look at r, x, and y, right? If you think about the circle, or the triangle, if I drew it, the triangle would have 3 things. This would be x, this would be y, and this would be r. So what I want to imagine in my mind is taking that multicolored triangle that I just drew and shrinking it back down till I finally get it so that the radius is exactly 1. Then it's back on the unit circle and we know how to do it from there. So the question is, what would you have to multiply r by to scale it down so that it's exactly 1? That's what we want to figure out. So let's pretend that we had a number for r. Let's pretend that this was a radius of 5. What could you multiply 5 by to scale it down so that when you do that arithmetic out, it turns into 1? Yep. 1/5. What if you had a radius of 8? What could you scale 8 by to make it exactly a radius of 1?
1/8.
1/8. So, what if you had a circle of radius r? What could you scale it by to make it a radius of 1? 1 over r. Yeah. Now, when you scale something, right? So let's, well, let me put these, I'm going to keep that here. Just put these in the other column. Because technically the r, the x, and the y, that's the big triangle. If we scale it by 1 over r, perfect. We've just made the radius 1. If you made the radius 1, that means you just turned your problem back into a unit circle problem. But if you want to scale a triangle, right? You got this side, and this side. And let's say I want to make that side smaller. What else do I have to do?
Make the rest smaller.
I got to make every side smaller, and I have to scale every side by exactly, well, it's hard to do it on the smartboard, but I have to scale every side by exactly the same amount. I didn't do the last side. But if you don't scale every side, you can see what happens. You've ruined the problem. So whatever you scaled one side by, you have to scale all the sides by. So we're scaling every side by 1 over r. And that's going to shrink down every side proportionally to be back on the unit circle. Okay. Now I want to multiply these two together. X isn't a fraction, so what could you put in the denominator if you wanted to make it a fraction? 1. And now just multiply straight across. What's x times 1? X and 1 times r. R. So look at what just happened. On the big circle, you had an x. On the small circle, it turned into x over r. So I'm just going to write down what just happened. X turned into x over r. I mean, I basically have it on the right, but I'm just making it even clearer here. What do you think I'm going to put right here?
Y over r.
Y over r. So y turned into y over r. Okay. All right, so when we scale it down, I'm trying to just show you what happens to all the sides. The radius turns into 1. That's what we want, so it's on a unit circle. X turns into x over r. Y turns into y over r. As long as you remember those two things, that's all that happens when you work on a circle that's not the unit circle. So I'm going to show you the same formulas that we did on Monday, except I'm going to keep in mind what I just circled right here. Okay. So all week we've been doing sine, cosine, tangent. What has sine been all week? Y. What did we just say y turns into? Y over r. Cosine has been x. X, when you scale it down, turned into x over r. And now tangent, what's the difference between the formula that I wrote for tangent here and the one we've been using all week? Yeah, you see? What's the difference between the formula I wrote for tangent there and the one that we've been using for tangent Monday and Tuesday? Yeah, nothing. It's exactly the same formula. Okay, so we just saw that tangent stayed the same. Well, before, this is what we were doing all week. Tangent was y over x. Y becomes y over r. X becomes x over r. But when I divide those two fractions, the r's just cancel out, and the tangent ends up being the same formula. Now, once we have the 3 on the left, what did we do to get the ones on the right? We just split them. So cosecant is r over y, secant is r over x, and cotangent is x over y. Okay, so just to be clear, the x and the y are coordinates, right? The x value and the y value from the coordinate. R stands for the radius of the circle. That's what I drew in red right there. R is the radius of your circle. Now, what, yeah?
Oh, wouldn't that just be 1 then? If it's supposed to be 1?
Well, if we're on a bigger circle, we'll do a problem in a minute, and you'll see. Now, what's the radius we've been working with all week? 1. Don't write this in your notes. I just want you to watch this part. But if I take all of these formulas and replace r with a 1, those are all the formulas that I taught you on Monday. So the formulas I taught you on Monday were really these formulas. The only thing that I did is instead of putting r in the formula, I made all the r's 1 because 1 is an easy number to do arithmetic with. We could have done this on a circle of radius 2, 3, right? I just picked 1. But those are the real formulas, okay, for any circle that you have. Okay, so let's try an example. We'll do one example for this, and then we're going to finish up with the calculators. Okay. So, example 7. I'm not going to do all 6 trig functions. I'm just going to do the sine, the cosine, and the tangent. And they're giving me the coordinate. That's one thing that they always do. If you're working on a circle that's not the unit circle, they have to give you the coordinate. They're not going to tell you to find it. Now, how do I know 5, 12 isn't on the unit circle? Well, just think about if you were to graph the point 5, 12. Here's the point 5, 12. Okay, I'm going to go right 5, and I'm going to go up 12. 1, 2, 3, 4, 5. That's 10, 11, 12. I'm just estimating. So that point is on a circle. It's on that circle. Is that a unit circle? No. Unit circle is right here. It's a circle that goes 1 unit in every direction. That's way bigger than the unit circle. Okay? So because of that, I know that I'm going to use these formulas. So I need to find 3 things. X, Y, and R. Okay. What's X in this problem? 5. Yeah, we already have that. What's Y? 12. Now, what we don't have that we have to find is R. What I just drew is R. That's R. If I go like this, does anyone have a thought how we're going to find R? Yep.
Hager here.
Yeah, Pythagorean theorem. Bottom side is 5, and the height is 12. And now we solve for R. So 5 squared plus 12 squared equals R squared. That's the only extra step in these kind of problems. You have to find R. So let's do that. 5 squared plus 12 squared equals R squared. Okay, what's 5 squared? 25. 12 squared? 144. If you add those up, you get 169. And what's the square root of 169? 13. Now, I picked one that came out nice because I didn't want to have to deal with square roots in this one. And that's it. So now we just plug into our formulas. So sine is y over r. So in this case, 12 over 13. There's your sine. Okay. How about cosine? Still involves the same letter we've been using for cosine all week. You just have to remember to divide that letter by r because it's like you're scaling it. It's x scaled by 13. Okay. So 5 over 13. And what about tangent?
12 over 5.
Yep, 12 over 5. And you actually didn't even need r. So if they ask you for tangent in a problem like this, you don't even need to do the Pythagorean theorem because r doesn't matter for tangent. For everything else it does. Okay. And if they asked for the other 3, what would I do with those?
Flip them.
Just flip them. Yep. Okay. So just remember, on a circle that's not a radius of 1, just take what you've always been doing and divide it by r. Just divide it by r. So y divided by r, x divided by r, and then tangent stays the same. Okay. So that's that part. And last thing. So when we're dealing with angles that are multiples of 30 and 45, that's fine. You do it on the unit circle just like I've shown you. Well, if I give you a number that's not a multiple of 30 or 45, we just plug it in on the calculator. So we'll go through one of each. We'll do a sine, a cosine, tangent, secant, cosecant, cotangent, and then that'll be it. Okay. Can somebody read that first one to me? Example 8. How did you read it?
Sine 18
Degrees, yes. Sine 18 degrees. That last part she said is important because when you use the calculator, there's 2 modes you can be in. You can be in radians or you can be in degrees. If you're using one of my calculators, I don't have a picture of one, but there's a button at the top that says DRG. And if you press the DRG button, then you get a choice. You can pick radians or you can pick degrees. You can just use the arrows and then select whichever one you want. So this first one, I want to be in degrees. So on my calculator, I know I'm in degrees because it says degrees right at the top. And then you just type sine 18 and then hit enter. So if you did it right, you should have gotten 0.309. That's approximate. It's not an exact answer. Everything we've done up until now has been exact answers with square roots. That's not an exact answer. It's rounded. So on this calculator, you press sine 18 and then enter. On some calculators, like this one, you do it backwards. You type in 18 and then press sine. So if you have a calculator that's backwards, I think it's kind of confusing. You can always use one of mine. Just make sure you know how to type it in if you're going to use your own.
I got negative 0.75.
And you switch the calculator to degrees?
I switched it to radians.
Yep, you want to be in degrees.
Degrees.
For this one, I mean, there might be a problem next that we do that's in radians. But for this one, if you see the little circle, you know it's degrees. That's a totally different question now. Now it's asking for the sine of 18 radians, which is probably what you got. Okay. Which mode should I have my calculator in for this one?
Degrees.
Yep, degrees again. So we just type it in. Cosine 356, 0.998. Anyone that didn't get 0.998? All right. That one, how do you read that one? Yeah. That's the tangent of 2.4 radians. Okay. So now I'm going to change my mode to radians. If I was doing it on a test, I might do all the problems that have degrees in them first, and then do all the problems with radians, so I don't have to like switch back and forth. It's up to you. Tangent 2.4. You should have gotten negative 0.916. What's that? You got it? Anyone else? Question on that one? Okay, let's look at this one. The cosecant of 247. Okay. So CSC, if you look at your calculator or mine, is there a button on there that says CSC?
No.
No. So you can still type it in, but there is no button for CSC. So think about when we did problems in class. Let's go back to one that we did earlier. How did we get the CSC there? What did we do? What did we flip? The sign. Yep, we flipped the sign. Yep. Right? So we have to do the same thing. They're asking me for the cosecant. Yeah.
I have to go to mine.
Yeah, there you go. So,
See you tomorrow.
yeah, we'll see you tomorrow. Instead of finding the cosecant of 247, what do you think I'm going to type in? The sine. And what do I want to do with it? Because I don't just want the sine, I want to take the sine and flip it. So we want to type it in like that. That's the sine flipped. And that's the cosecant. Now, if I hit enter, that's wrong. What did I do wrong? I didn't put it in degrees. Okay, very easy mistake to make, but because the little circle's there,
Wait,
Oh, I still didn't get that.
yeah, can we redo that? Oh, you just have to hit like 1 and hit divide. Oh.
so you type 1 divided by sine of 247.
No.
Yes. What?
How many people got negative 1.086? Looks like a lot of people. Anyone that didn't get it? You're not getting it?
No.
All right, let me see. We'll be done after the next one. Let me come look at yours and see if we can figure out. What kind of calculator are you using? One like that? Okay, yeah, it should work. We'll take a look at it and see. Right, how about secant of 6? Somebody tell me everything I have to do to use this calculator to get the right answer.
Change it to radians.
Yes, first thing I have to do is put my calculator in radians.
Oh, so when do you change to radians and when do you take it out?
If you don't see the little circle,
Okay.
like that's now a degree problem. If you don't see the degree, then you know it's radians. Okay, so I'm in radians, and now what do I type in? Ben?
Is it the cosine, or 1 divided by the cosine?
Yep, 1 divided by the cosine of 6. So you should have gotten 1.041. And the cotangent, how would I type that in if I was going to do that one? 1 divided by the
The tangent.
1 divided by the tangent. Yep. And make sure you are in degrees. Okay. All right, so we looked at doing the 30s and the 45s and all the other quadrants. So all you have to remember is to put a negative in the coordinate. We looked at what happens when it's not on a unit circle. We didn't really spend a lot of time on that. So that would probably be something you might see as like a bonus with a question that's not on the unit circle. And then, let's see. Yeah, the last thing we did is we looked at how to use the calculator. All right, so that's the homework for tonight. Okay, tomorrow will be a review. Okay, so we'll review everything that we've done this week for the test tomorrow. So 49 to 57, that's just the odds, and 67 to 81, that is all. And then 83 and 84.
So tomorrow, if I'm like confident, can I take it in my study, period 7?
Yes.
Okay.
Yep.